Welcome to Tutorial 3 on how to compute with MATLAB. In this tutorial, we'll become familiar with both while loops and for loops in MATLAB and use them both for the same problem of computing function values from a set of independent variables. Before we dive into any serious programming, let's just go into the correct folder for this tutorial. So just going into the current folder window, let's go into Tutorial 3. Now tutorial 3 is blank, we haven't created any scripts yet, and just for some extra practice, let's just create one new script. And all this script we're going to do is try to practice for loops and while loops. We haven't talked about while loops yet, but let's try to introduce them now. So going to new script, okay, brings up our scripting window, and we can just type in function to name this script, and let's just say something like testing loops. Open parenthesis, end parenthesis. And we can go ahead and save this now, testing loops, okay, into tutorial 3's folder. And we have this function. This function doesn't do anything as it stands, we've just named it. And of course we can go ahead and just write in some comments if we wish. So just pulling in some of those percentage signs and writing some comments, we can say the purpose of this function is to practice for loops and while loops. Now, before we practice either of these for loops and while loops, let's just take a moment and reflect on what the difference is between them, as well as what is a while loop exactly. First, let's quickly review for loops. For loops were first introduced in our tutorial number 2, and they're a handy way to iterate through a number of components of a vector or a series of numbers, just like we did in tutorial 2. So the times you use for loops are when you start thinking things like, for every number between 1 and 10, 1 and 20, do something. For every component in this vector, do something. We want to use for loops whenever we have a set start as well as a set endpoint. The pseudocode for this type of thing is rather simple. We pretty much just have to say for n equals 1 or for n equals wherever our starting index is until wherever n ends. So for example, if we're saying for every number between 1 and 10, we would say for n equals 1 to n equals 10, and then we want the loop to do something, and then we can end the loop. So for our previous example of for every number between 1 and 10 do something, the way we'd write this in MATLAB for the correct MATLAB syntax is very similar to the pseudocode. We just say for n equals 1, and then a colon, and the amount we're iterating by or incrementing by, which is 1, another colon, and then the value we're ending at, which is 10. And after that line, we just actually have MATLAB do whatever we want, perform whatever arithmetic operations, or whatever things we want to print to screen. And after we're done doing something, we can just end that for loop. So let's do an example where we have a set of numbers and we wish to compute the mapping of each of those numbers under some function. Say the function is e to the 3x times sine of x. And we just want to save each of those mappings to some vector y. And let's just use our set of numbers to be the numbers between 0 and 1 in increments of 0.1. And then we can do this in a few steps. The first step perhaps is saving all the values that we want to see mapped into their own vector x. And we can use MATLAB's kind of incremental based definition of a vector and say for x equals 0, colon 0.1, the increment we want to increase by, colon all the way to 1.0, the last value of the vector. Next, we can go ahead and actually try to write our for loop. We want to iterate over every component x of I of x. So we can say for n equals 1, going up in increments of 1 to the final length of x, or how many components there are in x, then we can actually do our something, which is define each component of y, and we can have them indexed by the value n, that n is changing for each increment during the for loop, to be equal to the exponential of 3 times x of that component n times sine of x of that index n. So now let's go ahead and try to just code this example for loop. So coming over to our MATLAB scripting screen, we can just start to do that for loop. So first, let's just do a couple comments and say practice for loop. And of course, here's where we put a comment on what this for loop's actually doing. Now, if we remember correctly, we wanted to define a vector of values between 0 and 1 that are incremented by 0.1. So we can just do that in MATLAB simply like we did before, as saying x is equal to 0 colon 0.1, what we're incrementing by, all the way to 1. And just putting the semicolon at the end just suppresses the output from popping up in the command window when we run this script. Next, we want MATLAB to loop over every component of this vector x. So to do that, we can begin our for loop by saying for, and then our indexing variable, which we can just use n, say n equals 1, the first component, what we're incrementing by, which is 1, and then we want to say until the last component of x. And MATLAB has a built-in function that's called length that will just give us the length of the vector, or in other words, the number of components in that vector x. So our for loop is pretty much initiated, and we can just end it. Of course, what we have to do now is actually in the middle of this for loop, actually do something. And this is where we wanted to find that vector of y values. And we can define that vector of y values just by indexing y as n. So as n goes from 1, 2, 3, all the way to the length of x, y will be incrementing as well. And this we said was equal to the exponential function, where MATLAB has a built-in exponential function, exp, left parenthesis, and we said this was times 3 times that component of x. Now x's we can also index by n, since we're looping over every component of x. So we can just say the nth component, and then close the parenthesis for that exponential. Similarly, there's a function for sine, just like there's a function for cosine, tangent, arccosine, arcsine in MATLAB as well, that's just adaptly called sine. And we can just call that as sine, open parenthesis, x of n, the x component, or the nth component of x, close parenthesis, and then semicolon to suppress the output. Now if we save this, let's just have this print to screen. And let's print to screen as y transpose. And the only reason for a transpose is so we have a column vector instead of a horizontal vector. So let's save that and go back to our MATLAB command window and try to run this script. Remember, the script didn't take any input, so we can just say testing loops and enter. And then we see all these values of the subsequent mappings of each component of x under that mapping e to the 3x times sine of x. Now next, let's try to do the same exact thing, but it's using a while loop. So let's now introduce while loops as well as try to program the same type of example. Now let's introduce what a while loop is. While loops are a handy way to continually do something until a certain condition is met, rather than a for loop where we know exactly what components or what numbers we're going to iterate over. A while loop can continuously just keep looping and looping until a certain logical condition is satisfied. So a lot of examples could be something like we did previously. While we haven't iterated through every component of this vector, do something. Or perhaps what's more traditional in math is when a computed error is greater than a specified error tolerance that we want, keep doing that operation until we can satisfy that error tolerance. Now the pseudocode for a while loop feels very familiar. We just have to say while this logical statement is not met, keep doing that operation over and over. Now the subtle thing here is, well, we have to update this logical statement each time we're in the loop. Otherwise, if this logical statement is just continuously not met, our while loop will literally try to run forever. So this is an important intricacy of while loops. We're going to be in charge of updating that logical statement, or updating the incremental number or the index or the error of that particular loop iteration. We have to make sure that our while loop is actually able to finish at some point. So let's go ahead and try to do that same example we did earlier using for loops, except this time let's try to use a while loop. We can do the same first step, which was define that vector x to be between 0 and 1 in increments of 0.1. However, for while loops, there's a few more things we have to consider. First, we have to know how many components there actually are in x, so that we don't try to iterate over a component that's just flat out not there. Next, we have to create our own indexing variable and manually update it or increment it each loop iteration so we can keep progressing through that vector. This is not handled automatically in while loops like it was for loops. Now let's go ahead and try to write out what this while loop would look like. First, let's define n to be the length of the vector x. This will tell us how many components there actually are. Next, let's create the indexing variable, which we'll call lowercase n. We'll be in charge of incrementing this every single loop iteration to go through each vector component. Now we can initialize our while loop and say while little n is less than or equal to big N, or the number of components of the vector x, keep iterating through that loop. And now this is going to be important because we have to change the value of little n such that once this logical statement is not true, then the loop can end. Now, as we're looping through each value of n, we want to be setting the corresponding component of y equal to that value of the function x being mapped under that each of the 3x times sine of x function. And we can set that in the same exact way we did for the for loop. Now, the important thing that we have to remember is that we have to update the value of little n, or our indexing counter variable for this while loop. If we did not do this, the while loop could just presumably run forever. So we have to update the little lowercase value of n just by saying n equals n plus 1. So each time it goes around that loop, it's increasing the value of n by 1. Okay, so now that we have an idea of how to answer this question using while loops, let's go ahead and try to test that in our MATLAB script. Okay, so to actually practice our while loop scripting in MATLAB, we have to go back to our MATLAB script that we called testing loops. And before we do anything for the while loop, let's just rename this variable y and say this is y4, meaning this is our y variables that are coming out of our for loop example. And let's just suppress the output by putting that semicolon. Next, what we can do is basically write our comments just to say we're going to practice some while loops now. And then we have to start to think, how are we going to actually implement our while loops? Now, if we remember from the previous couple slides, we had to first define how many components there actually are in our variable x. And on that note, we actually, since we already defined our variable x up for the for loops, and we didn't change the values of x anywhere in our for loop, that same value of x will come down the script and we can use it. So to give the number of components of x, we can say capital N, just our variable name, is equal to the length of that vector x. And that'll give us the number of components of vector x. The next thing we had to initialize was our indexing variable, or our counting variable, as we loop through that while loop. And we called this little n, or lowercase n, and this we just start at 1. And we just give this a nice little comment saying this is our indexing variable for the while loop. Okay, to actually start the while loop, we can just simply write while. And just like the for loops, that while turns blue, and we just have to say, what do we want? We want to say while little n is less than or equal to big N. And the way we can write this in MATLAB is by having little n, the less than sign, the equal sign, and then capital N. And this is going to be our condition that our loop's going to continuously run until the value of little n is greater than that of the value of n. And we can just go ahead and end this while loop. And now in the middle of this while loop, this is where we actually want to do something, just like in our for loop example. And let's call this, and what do we want to do here? We want to find each component of y as the component of x being mapped under that function e to the 3x times sine of x. So we can say y of while indexed by n is equal to pretty much exactly what we had before, MATLAB's exponential function of 3 times the nth component of that vector x times sine of that nth component of vector x. And that'll give us all the values for our while loop. Now let's just go ahead and see what happens now if we try to run this. And of course I just took away that semicolon, so the output's just going to dump into command window. But the thing we have not done yet is update the value of little n. So our value of little n right now is still set at n equals 1. Let's go to the command window and just see what happens when we run testing loops. We get the first value, which is apparently y equals 0, and it's just running forever. And we can see it running forever because this bar is just bouncing all over the place. And we can kill this command with Control C or Control period. Or Command period, excuse me. So now let's go back to our MATLAB and suppress the output from that while loop, but now we have to actually update our counting variable where little n equals little n plus 1, meaning that each time we go through this loop, we're going to be adding 1 to the value of n so that we can actually effectively iterate through that entire vector. And let's just see what the output looks like. Y while. And let's do that same transpose so we get a column vector. And let's go back up to the y4 and take away that semicolon just so we can compare outputs to make sure we're doing the same thing. So going back to the command window, let's just clear it, CLC, enter, and let's just run testing loops again and see what happens. And lo and behold, we have two column vectors that both have the same data in them. So at this point, we've done the same thing for both while loops and for loops and compared their subtle differences between each type of looping in MATLAB. Now in comparing both for loops and while loops, they can be used for the same purpose like we just saw. However, while loops and for loops do have their own advantages and disadvantages over using one or the other. So for example, with for loops, remember we said it's a handy way to iterate through an array or a series of numbers that we know. So this is basically saying that we will only iterate for a certain amount of time that we're aware of. Whereas while loops, they can just continually keep going and going until a logical statement or a certain condition is met. So they don't have to go just 10, 20 times. They could go 150 or an unknown amount of times until a certain condition is met.